All right, welcome back. We are INFR3335U, and that's in the fall 2021 semester at Ontario Tech University, and it's week 10 instead of part 1. It's actually part two of our broadcast. And what we're doing now is we're going to be covering a couple of tech demos, one for platform detection, and the other one that's for on-screen controls. We're shifting gears a little bit for today. And what I want to do is I want to start a brand new project. So just to be able to do that, or maybe we can continue with a project that we have. And again, I want to do this, simply for exposition purposes, not for that I'm going to use this project. So let's make a new project, right? And we'll just call it, it'll be a game that's using Unity 2021.1 19F1, which is the one I'm using. I'm going to use 3D mobile. Okay, so this is the template that I'm going to be using, and let's just call this from a project perspective, we'll say it is INFR 3335U in the fall 2021 semester, and it's week 10. Okay, so we'll make sure that it goes into the right folder, right, which is Ontario Text folder, and we'll see how this works. So we haven't done it for a while, but let's choose this folder and go create project. So when it comes to on-screen controls, and again, I'm just pulling up Unity for us to do this. You can choose your version of Unity. Hopefully you're using something compatible with me. I want to cover things that we've already covered before. I'm going to actually start with on-screen controls. So if I have an on-screen control and I want to use some kind of movement or jumping or motion or something like that, we got to consider what that is going to look like. Okay. So let me just do that, and I'll just get prepared for me to talk about it. And give me 1 second, and I'll pull it up. All right. Let's see if I can pull up some stuff that makes sense while we're pulling up our player behavior. Okay, and maybe even the camera controller. All right, let's do this. So I'm going to cheap out on some of the stuff I'm going to do because we don't have a lot of time. And inside of our sample scene, here's where we start off. We're starting in scenes. Remember that what I do a lot of times is I start off with a squaring things off. I say this is scenes. Again, I want to create a new folder. We'll call this scripts. And we'll make a very simple movement script for us and so on. So again, what I want to do is set up some basic building blocks. So in scenes, let's go with our main scene. And let's add in a couple of things that we need. I'm going to add in a 3D object cube, right? And what we're going to do with this cube, we're going to call this ground. Here's the ground plane. And I want to kind of expand it so it's like maybe a lot wider than that, something like 20. And not that way, but actually this way. We're going to make it kind of long and make the ground 0.1, something that's really small. So it's kind of a cubic plane for the ground. And I also want to add in another material. So let's go to the materials folder. And inside the materials folder, I want to add in some simple stuff. So let's look at a material. We'll call this the ground material. And we'll choose a brown color. And we kind of did this. There's some fancy stuff we can do with brown. So as an example, if I want to look at a hexadecimal brown color, so brown hex color, there's some really great brown hex colors you can choose from. And let's say I wanted to choose something like a peanut color, so hashtag 795C34, right? So I can do that, right? Hashtag down here, 795C34, right? So C34. Makes it that brown color. That's what I want. That's the ground. We can kind of tag that on. There we go. So really, really quick and dirty ground, right? Let's also add a couple of things for me to use. I'm going to add a camera. Let's create some fly-through controls for my camera. And that's what I will want to make today. So I have a ground, but I want to kind of zoom around the ground. Maybe I have some other things that I want to inspect with my game. Let's add a couple of 3D objects. So let's add a sphere, and let's pull that sphere here. And we'll say that there's a couple of spheres we want to create. Let's add in a couple of colors. So let's copy the material, and we'll call this the sphere material. We'll call this red sphere. And the red sphere will just be all red. Again, we want something to start with. That's why I'm doing this. Not because I want to waste your time by any means. All right, so here's my red sphere, and we'll make a green sphere material as well. Create, actually, we'll just Control D it, and we'll just make that the green sphere. Red and green spheres. Yay, so exciting. And the green sphere will be all green. So we're just going to turn that in green, use that, and copy the sphere. So we're just going to Control D that, and we'll call this the green sphere, which we can make a prefab later, and the red sphere. There we go. Take that green sphere and pull it out over here, and we'll just take that green sphere material and put it on there. There we go. Hey, look at that. So exciting. Okay, so now I want to make some scripts to move around my camera, right? Because that's kind of the exercise I want. I want to move my camera around, and I want to use the joystick to do it. Okay, so I want to do that with on-screen controls, right? So I got to consider how this is going to work. Okay, so, and bear with me while I'm doing it. I'm not going to make a character that's going to touch the ground or anything like that. That will just take too long and eat a lot of our time. So I don't necessarily want to go there. All right, so let's think about how this will look. And let's just look at a script that I want to pull together. So let's make it. So again, under scripts, I want to make a brand new script called a camera controller. So I want to make fly-through controls for my game, right? And my camera controller, we're going to use Visual Studio for this, right? So I'm going to move around the camera, right? And we'll quickly draft up something that makes sense. Okay, so again, what I want is a header. And the header, it's going to have some look controls, right, for the header. And we'll have a public float sensitivity, right, which we'll assign something like 10 to. Maybe that's too much. And maybe another header for, for movement. We're going to move the camera around, right, as an example. And we want to have some public float max speed. Come on. Come on, computer. Yeah, max speed. ReSharp or C++, right? And ReSharp or C#. All right, so max speed is going to be also 10 here. And we're also going to add in a vector3 for velocity so we can see the velocity. Public vector3 for velocity. And we're also going to have some private variables we're going to use. A couple of them. One of them is going to be called x-axis rotation, which we're going to start off at 0, 0, which is going to be a float type. And we're also going to do the same thing with y-axis rotation, which is going to make that 0 as well. I'm thinking about other things here. Quick, Tom. What can I do quick for you guys? Let's do another header that is going to be called panel controls. So I want to add that in too. Because we're going to have some controls that come in. And for now, we're going to have a public game object. We're going to make a public game object, which is going to be our control panel. That's going to kind of be there. We can turn it on and off. Do that. And we also want to keep track of, at the beginning, we're going to kind of start thinking about the mouse as our first set of controls. So private vector to mouse, and we're going to kind of have both touch controls as well as keyboard controls. Okay, that's what I want to go to. In the update function, I want to have two functions that are going to be called. One of them is going to be a private void mouse look function, and the mouse look function is going to be my mouse look code, right? And it's going to look like this. I want to get input, at least for now, from the mouse. And by the way, mouse look is going to turn into touch look. So I'm going to kind of touch this and move my finger up and down and get some kind of input from my finger touch controls as opposed to the mouse. That's what I want to do. For the beginning, I want to say that my mouse X is equal to, we'll use the old input system, input.getAxis raw. Actually, we'll just use x.getAxis. How about that? And we'll say mouse X and multiply by sensitivity. And then mouse Y will be input.getAxis mouse Y. So we'll get mouse controls multiplied by sensitivity because we want to make sure that that goes good. We want to look up and down first thing, and I want to say that x-axis rotation is minus equal to mouse Y, and x-axis rotation is equal to, we'll clamp it, mathf.clamp, and we'll clamp it between the x-axis rotation number and kind of an angle between negative 90 and 90. All right, so that's where it's going to go. So simple stuff. And then I also want to have look left and right kind of controls and rotate around the y-axis because y is up in Unity. We're going to say that y-axis rotation is plus equals to mouse.y. And finally, we want to rotate. The rotate function is going to do it all for me. It's going to say transform dot local rotation, and that is going to be equal to a quaternion Euler. Okay, and I'm going to start off with x rotation and y-axis rotation with 0.0f. So what this does, the quaternion Euler, it gives me a x, y, and z, and I'm telling it how to rotate. I'm going to rotate across both the x-axis and the y-axis in order for me to do the proper mouse look. In the update function, I'm just going to call this mouse look. And for now, we don't need my house is burning. We don't need my start method. We'll just get rid of that. And that is my code for mouse look. Samuel asks, what are these headers for? Is it just organization? Yes, it is. So headers are exactly for that. So when you actually look on the editor, sorry for the noise, when you actually look at the editor, you're going to see that the header is going to appear in the inspector. Let's take a look. So I'm going to save this script, and I'm going to go into my camera. Lots of ways to do the same thing, by the way. We can also use Cinemachine, but let's just use camera controller and pull this in. And you can see now that I have some stuff, right? I don't have a panel yet, but I'm not using it, so that's okay. And if I press play, if we did everything properly, then you can see now I might have some kind of camera controls. But why is it that my camera is locked? I can move up and down. So let's take a look at my camera. We'll look at it in kind of a split screen. So let's pull that down there. Come on. Doesn't like it today. So here it is. So we can look at it kind of in a split screen, right? And here's what we're looking at. We'll look at 1024 by 768 and take a look at my camera controls here for a second. So here's something, right? I have my camera controls and I want to start rotating. So how does this work? So if I press play, take a look at what my camera controls do. Right? And let's turn on gizmos so you can actually see the camera. if I click on the camera, you should be able to see what the camera is looking at. So again, if I move up and down, right, the camera should also move up and down. And if I move left and right doesn't seem to be working. Just like take a look at that. So I'm getting kind of a direction right and left. And when I start moving, right, it's rotating. It should be rotating to some degree across this time. This part looks like okay. But when it comes to, you know, moving left and right, that left and right stuff seems to be a little broken. Okay, so let's fix that. So let's take a look at my code, and maybe you can feel or you can see where this isn't working. So again, y-axis rotation and x-axis rotation, y-axis rotation. We're getting mouse. We're storing the mouse input, and what we're really saying is that you know, when I'm doing the mouse look, right, mouse.x is on the x-axis times sensitivity, and that seems to be right. I'm subtracting mouse y from my x-axis rotation. Let's make sure that that's correct. Minus 90 to 90, that's the clamp. Mouth f.clamp, x-axis rotation is working okay. And y-axis rotation is doing this. Let's make sure this is correct. Transform, oh, is that incorrect? X-axis and y-axis, that should do what it's supposed to do. Why does that not work? And so we can start separating some of this stuff out. And what if I only want to try one thing at a time? I'm trying a lot at once. And sometimes when you do this, again, example is if I want to move left and right, then we're adding this. That's where the problem is. This should be mouse X. There we go. Okay, good. Let's try that now and see if it works. Yes, thank you for that, Jonathan. And we'll just pull this up here. And that should be pretty much close to what we've done. Let's take a look. So now we should be able to do mouse look. Mouse look looks okay. That's good. And we're just using our mouse for that, but we're going to use our touch for this next. Okay, cool. Next, let's go and do movement. So I want to do movement next. So there's my mouse look, and then under mouse look, I'm also going to put this up on Canvas later on for you guys, so you can always access the code if you need it. I don't think you will, but hey, why not share? So we'll make a move function, and the move function is going to be using our input controls using the old system again. So we're going to say float x is going to be equal to input.getAxis raw, and we're going to get the horizontal, and float y is going to be to input.getAxis raw vertical. And I want to make my own. I want to make a Z that uses, because I also want to have E and the Q button also move me up and down, similar to what I can do in Unity. So if I was to go in the scene, if I press the right mouse button and I press right and left, I can do this. But if I press the E button, I can rise up and go down. So I want this rising up and down control to be attached to the E and the Q key. I don't have an axis like that. So what I'm going to do is I'm going to make it. So I'm going to say File. Actually, I'll go Edit, Preferences or Project Settings, right? And in Project Settings, if I want to look at the input manager that we have, I have these 18 axes. And notice I have two horizontal axes. I have a horizontal and a horizontal. I want to rename this horizontal axis, the second one. I want to rename it to up. You can do that. And what I can describe is a negative and positive button. So the positive button will be the E key. So positive button is going to be the E key. And the negative button is going to be the Q key. So I'm making my own little axes, if you will, right? E and Q. And let's just take a look at the horizontal axis to get some of the dead zones correct. So it uses a gravity of 3. I want it to react the same way, and a sensitivity of 3 with a dead zone of 0.01. Let's just copy those in. Nice, nice. Excellent. And it's going to be a joystick axis, but we can call it a key or mouse button. That's what it's going to do. Key or mouse button for the up. All right. Pretty cool. So this up axis is what I'm going to be using for moving up and down, making a custom input control with the old input manager. How does this work? Well, what I can do is I can also get in the case of mouse float X and Y, I can do float Z, and that'll be input.getAxis raw, and I'll use my new axis called up. I just made that. So now we can use some hacks to make this work. I'll use a vector3 move forward. And what I'll say is when I move forward, I want my vector3 dot move towards. I want to use the move towards method. And I want to start with vector3 0, right? So vector3 0, that's the current position, right? And I want to transform, transform my current transform, come on, current transform dot forward, wherever the camera is looking is the direction that I'm going, multiplied by max speed, right? And I want to take the y, my y-axis on the vertical, multiply that by max speed, right? And multiply it by time dot delta time. And I think I'm doing this correctly. Time dot delta time. All right, so that is going to give me my motion forward, and we should really test this. In order for me to make the move work, I'm going to use my transform dot position and plus equals the move forward vector. I'm adding it on to wherever my current position is. So I'm taking my transform forward, wherever that is, right, as an example, multiplying it by max speed, right, and then multiply my y by max speed, but multiply my y by times dot delta time in order for me to move forward in the right direction and the right speed. Now, if this isn't any good, and for example, if I'm getting a really fast, speed, I can change the max speed, whatever it is. Now, why transform forward to max speed? Well, move towards says two things. I need a current location and my target. My target, when I do transform forward, that is a normalized vector that looks out from the camera, and I want to multiply that by my max speed to get the length that I want. That's how far I want to go, right? At one blow, right? That's the maximum distance. And then I want to take my actual move and multiply by time dot delta time so I can continue shoot forward in time. All right, so let's try with just the move forward piece first. And what I'm going to say is after I mouse look, I'm also going to do a move. This is the first piece. Okay, so if I do that and go back, and if I try it out, let's see if I can move forward and back. So again, I can look around and move forward, and I can move back, and I can look around, and I can do this now. I can move, kind of fly through just by moving forward and back. It doesn't give me complete control. I can't go left and right. Wow, that's a terrible, look at that shadow, it's terrible. But what I can do is I can move forward and back. Okay, let's add the other one. So what if I wanted to do move sideways? Let's copy paste. This is a hack. This is my hack that I talked about, move sideways. So if I want to move sideways, I'm going to start with vector3 0. And I want to, instead of transform forward, I want to go to the right. Sum max speed, right? And instead of y, I want to start with x, right? And then multiply that by max speed times time dot delta time. That's move sideways. Let's add that on to move forward. So plus move forward. Here's my hacky way of doing it. And when I kind of run it now, we should be able to move forward and sideways. So let's try this. So move forward and move sideways. Hey, did I make a mistake? I probably did. Vertical, and I did the y, x here, and the y there. What did I do wrong? Y max speed, move forward. Oh, move forward twice. Duh. Terrible. Let's go back. At least you guys are watching. Yay. I know, I love it. Move forward twice. And let's try this hacky way of doing it. And now I can move sideways and also forward. right? So that's pretty good. I've got a lot of control already with my camera. Okay, one more thing. Let's move up now. That's the one that's missing. So again, we did move sideways, move forward, and the last one is move up. So we'll do a copy paste. Hacky, very, very hacky. And we'll say move up. Move up is going to be move towards, starting from vector 30, transform dot up is the direction I want to go, times max speed. And then instead of y and x, it'll be z, right? And then multiply by max speed time delta time. And I'm going to add that on to the end. Tack it on. Tack it on. And I can kind of do all those at once. Let's see, so I'm only adding vectors together. I'm making 3 vectors, adding them together, and adding them all onto my vector menu position. If you think about this as a way of calculating velocity across three axes in a very hacky way. Okay, let's try this out and try it out, see if it works. And let's run it, and let's see if I can rise up as well as do everything else. So again, if I rise up, that's cool. Go down, left and right, and I can move forward and back. I've got full control, guys. Yay, right? Pretty good. My scene sucks, but it's okay. Cool, excellent. And I've got WebGL 1024 by 768. Let us file, save project, and let's put this, let's do a couple things. Let's exit, right? And I'll put this up on GitHub. Again, people have been asking for this as well. I'm using GitKraken, but you can use whatever tool you want. And so you can access this thing later on. So let's do that. So let's make a new repository. So start a local repo, right? So if I start a local repo, I want to target where I want to look. I want to look at my Ontario Tech University inside of my INFR3335. And I want to look at just this outside folder first. And then when I click browse again, I want to grab that name, which is week 10, copy it, but without going into it, and put it there. Okay, I could have typed it as well. I want to select a gitignore file, which is Unity. And my license, let's make it MIT. Don't have to make it a license, but I'm just adding it in. And then I want to create my repository. Boom, it's done, right? And I got 44 files. Let's stage all changes, and we'll call this added project files. It's pretty quick. Commit all changes, and I want to push up to GitHub, right? So I don't have a remote, but it's going to create one, and I'm going to put it up on my Ontario Tech University account, this one, where I'm going to share it with you. And it's going to be public, so I can create remote and push local references. And then I'm going to get a GitHub repository that I'm going to share, which looks like this. Let's do one more thing. Let's change the README file so that it says it is a bit of information. So I'll say demo project for INFR3335U in the fall 2021 semester, week 10, right? Something like that. And let's add that in. We have a commit that's up online. That is, so now I'm one commit ahead of my local repository, local here. You can see that there's an incoming commit. I can pull that, and now I'm going to be in sync. So again, that's all the ways we do GitHub that counts. And let's go back into Unity and continue. So now what I want to do for you guys is, if you need to access this repository so you can follow along, you can always download it and start from here. I'm using 2021.1 19F1, but you can go and do other versions of 2021. Even 2021.2 would probably work. So copy this, and let's put this inside of our canvas. So we'll add that in as an external link. I'm going to do that here so you can eventually see it. We'll say GitHub link for week 10 lecture. Okay. And I'm going to make that available to you. Actually, you should see it in Canvas now, just in case you need it. Okay, awesome. So that is, I just did that off screen, but it's just right here. GitHub link for week 10. All right, cool. So that is where we're going to go. I'm going to start off week 10 again. And now let's add some on-screen controls to do the same thing. And then we'll also do some detection, right? We'll do some detection and see how we can detect the platform. Okay. So what I want to do is whenever I add on-screen controls, first of all, I want to switch my layouts. Right now my layout is a 3D layout, but I want to do a 3D layout that I want to create that's going to be in landscape mode only. So I'm going to have my phone work landscape mode. So let's choose 3D layout for mobile. But instead of this, I want to choose the same thing, but I want to put my simulator below here. And I'm going to switch this way. So this is where my safe area is going to be, right? I'm just targeting a Samsung Galaxy S10 Plus. That's the default phone I'm using. Doesn't matter. You can choose other ones if you want. Okay. And what I want to do here is put some on-screen controls. Let's put on the safe area so we can see what the safe area is here. We want to keep this in mind for different kind of screen sizes. Okay. All right, so that's the first thing. And let's save this layout as the layout that I'm going to use later on. I don't have it saved. Again, you can do that by going to Layout, and I want to save layout. And I'm going to call this Tom's 2D mobile layout, and we'll call this landscape. There we go. So I can always come back to this exact layout later on. And you can see that indeed it kind of gives me landscape and portrait. Okay. Awesome. And now what I want to do is add some on-screen controls. Let's go into 2D mode here. So right into 2D mode, right? So I can see my canvas. I want to add a canvas to the screen here. So again, I'm going to go into UI and I want to add in a canvas. Here's my canvas. And the canvas is abstracted. So I'm going to move out all the way so we can see it. There's my canvas, but it looks like the same size as this thing, which is what I want. Okay. So first thing, make sure your canvas is showing, right? And one thing that I want to do with my canvas is I want to make sure that instead of my UI scale mode as constant pixel size, I highly recommend changing to scale with screen size. I'm going to give this a reference resolution that's going to tie into my LD player. So remember, LD player, I'm targeting a Samsung Galaxy S10 Plus, and my Samsung Galaxy S10 Plus reference resolution is 3040 by 1440. So if I look at my reference resolution, it's 3040 by 1440, the width and the height. And that's the same resolution that I want as an example for this. So inside of my canvas scaler, which is in the canvas itself, my X, right, is 3040. That's my reference resolution. And my Y is 1440. And I'm going to say match width or height and give myself 0.5 as a reference. Okay. So what this does is it makes my canvas adjustable or scalable according to the size of my screen. So if I change screen sizes, if I go with an iPhone, it's still going to work or look the same. Okay. That's number one. Second thing I want to do is add some on-screen controls. And I don't have a joystick, but I'm going to download one from the store. So I'm going to go Window, Package Manager. And inside of my Package Manager, right, I'm going to go into My Assets. And I'm going to search for Joystick Pack. Joystick Pack is a free pack that's available on the Asset Store. So if I look at the Asset Store itself, it looks like this. This is the asset pack that you can download. I'm sure that Stephen is probably using something very similar. But that is the asset pack from the Asset Store, the Joystick Pack. And I'm going to import it. Yeah, I'm sure he is, because we talked about it. And once I have it here, you guys should be familiar with the Joystick Pack. So here's my Joystick Pack. I have several prefabs, and one of them that I want to use is called a fixed joystick. You can use other ones. I like the fixed one. Let's take that fixed joystick and put it inside my canvas. So I'm going to grab fixed joystick and put it there. And now you're going to see it pop up. But I feel that the fixed joystick is too small. A lot of times it should be like double the size. So let's take that fixed joystick and multiply the scale by 2. Otherwise, your fingers are going to be way too small to hit this thing. And let's move it across here, and we'll move it up so that's inside the safe area. And that's nice. Nice. Excellent. But the problem is when I'm doing this that, well, what about if it was, instead of a Samsung Galaxy S10 Plus, if it was something like an iPhone 12 Pro Max? You can see that has a different safe area. The safe area is actually truncated at the bottom, right? So it's a little bit not as tall as the Samsung product, right? And if I want to cater to other types of phones, which is what I want to do for sure, then what I want to do is move this joystick up into the safe area, at least for now. And this is, again, a hack. There's other ways to do this, right? But I want to be able to do this for my phone. Now, this is without platform detection. This is just switching my simulator, okay? So that's where I think it is. So my numbers, if I was going to guess what this is, and if I put this back to the Samsung Galaxy S10 Plus, which is my reference phone. Okay, it's a kind of a general phone that fits a lot of different other sizes that I'm using. Then you can see that the position of the joystick points to the bottom left corner of the canvas as an anchor. And what I want to do here is, my position is 529. Let's make it 530. That's a pretty good size. And instead of 414, let's make it 415, just to give a nice number to this thing. Okay, so again, 530 by 415. And that's good. So what I want to do with this, with my my stick here, this one stick I want to use. So, I mean, typically what we do is if I have a controller, right, then what do? I move forward and back, left and right, you know, that kind of stuff. That's how I move with my controller. So forward and back, left and right. There is no up and down, however. I don't have an up and down kind of control I could put here, but that is definitely something I can do. So forward and back, left and right, no up and down. It's okay. At least we have some of it. Cool. I like it, right? But we need some way of scripting this so that it works. Let's add a couple of things here. I'm going to add a empty. So I want to add an empty, and I want to call this empty game controller. And in my game controller, I want to add a game controller script. So let's do that. So create a new C# script, which is game controller. And that game controller script, I'm going to drag and drop on there, like so, whenever it actually gets created. Come on. Going faster than my system can handle. And once I've done this, okay, so there's my game controller. I want to script it so it takes the joystick and I can do something with the joystick, right? So the joystick itself right now, what I want to do is take that joystick and get input from it eventually. Okay, for now, game controller is going to be there, and it's going to also have access to the canvas, right, where I'm going to have my joystick. But I want my joystick to actually be something that I can get input from in my my game controller. So my game controller, or my camera controller, is going to take input from my joystick as well as from the keyboard. All right, so let's do the camera controller first. So go back. Come on, camera controller. Oh yeah, I love when I'm doing multiple things at once. Sure. All right, so here's my camera controller, and one day where it reloads. I want reference to the joystick. So my panel controls is my panel. I want to turn off and turn on my panel for my so I can detect when my panel is off or on. But I also want input from my joystick, right? So we'll say look controls and movement. We'll say something like header on screen controls, right? And one of them will be a public joystick. Now we can get the joystick reference because we added the joystick pack. We'll call this joystick. Joystick, which is awesome, out of the box has horizontal and vertical. So just like we've done this, mouse X is input.getAccess, and I have my mouse X and mouse Y, Well, I want to use these. If I'm going to do mouse look with a joystick, I'm not, but if I'm going to mouse look with a joystick on this one, then I would just add it in. Here, I only want the move controls to be added with the joystick, so I can go kind of forward and back, right, and then left and right. So horizontal would be the joystick horizontal. So I can just add that in. I can just say something like, hey, let us add my joystick dot horizontal. And you're going to say, wait, what? How can you add horizontal twice? Well, remember, we don't get both controls. We only get one. Only one type. Can't do both. And the same thing goes with vertical. I can just add that in, joystick dot vertical, and we're good to go. So touch control is made simple. So now I will be able to move forward and back, left and right with my touch controls instead. So I go back, and let's check this out. And if I press play, it's going to crap out because I haven't found my joystick. And I didn't add that into my camera. Camera needs a joystick. Let's just drag and drop. And by the way, we can call this the left stick. So just click on this and say left joystick. Maybe we'll have two. There we go, left joystick. Maybe we'll make another one so we can do look controls for the other one. And let's try that out again. Come on. So if I do this now, you can see it's left and right, up and down. Works great, like a charm actually. Okay, nice. Let's add another joystick. So instead of buttons, we can make a play button or whatever, but let's add another joystick. So we'll just duplicate this one, Control D, right, for the right joystick. And I'm sure you've guessed what I'm going to do, but let's go back to the camera controller. And in the camera controller, we have our joystick. Let's rename this thing. So we can do a refactor rename. We can call this joystick the left joystick. And we can get another reference to the other joystick. Sure. We can get another reference to the other joystick and call this the right joystick. And the right joystick is going to be something that we want to position on the screen as well. So now that I have both, just a second, let's drag and drop or Control D this one. So Control D, we'll call this the right joystick. And we'll make this one work the exact same way, but we'll put it on the other side, right? Now we got to be careful on the right side, just like on the left side, we'll have two joysticks, just like we normally do with first-person controls for the camera. And right now the joystick is aligned to the left. We want to kind of anchor it to the bottom right. So we want to mirror it. So if this is 530 and 415, then this would be minus 530 and 415. Okay, so that's good. So both the left and the right joystick are there. And we're in the main camera. We're going to take the left joystick and the right joystick and drag them in again. Left joystick, right joystick, and we're good to go. So what do I want to do with my right joystick in the mouse look function? I'm going to say that, okay, well, I'm going to get input from the X and Y coordinates. So how would we do this one? Because I'm getting X and Y. So X goes, kind of left and right, right? And that would be my horizontal. And Y goes up and down. That would be my vertical. So what I want to do is kind of get a couple brackets going. And I want to say that, actually, let me just do that change again. The sensitivity is only really good for my, right now for my mouse. I don't know if I'm going to use it or need it for my joystick. For now, I'm just going to add on the outside. I'm going to say let's just kind of add this together with my right joystick dot horizontal. And I can do the same thing where I can multiply. I'm just going to ignore my sensitivity for now. We can redo this later if we find that my right joystick dot vertical is good enough, right? If it's without any kind of sensitivity changes. right? Sensitivity actually drops the sensitivity, not increases it, more or less. Let's see how this works. Maybe I'm wrong. We'll see how it goes. So again, because one's a joystick and the other was a mouse, we'll see how it goes. Okay, so play. And if we did everything correctly, then we should now be able to do both. So I should move up, down, left, and right, right? So I can kind of scroll around. That's pretty good, right? And up, I can only go so far. Down, I can only go so far, right? But left and right, I can do whatever, right? And I can also do forward and back. If you had a mobile controller, I could do both at the same time. I don't. It's hard to use touchscreen controls at the same time, right? That's really hard to do, okay? Possible for me. So there we go. So this, I've just added 2 joysticks, and I've basically simulated what it would be like to use touch controls or keyboard and mouse. I have both now happening at the same time, and this is good. Now what I want to do, and this is a challenge, right, is I want to surround the joystick, left joystick and right joystick, with another empty object. Warning, I got to warn you here when I do this, what's going to happen. So if I do this, and if I wrap it in an empty, what you want to do with this empty is you want to make it stretch. So it stretches to the size of your screen, okay? And this is kind of cool because what it does, this empty object, we'll call this the on-screen controls, right? And what I want to do is when I'm detecting, when I detect my on-screen controls, as an example, when I'm in a mobile build, I want my on-screen controls to work. But if I'm in a WebGL build or a Windows build, I want my on-screen controls to be off. Okay? So that's what I wanted to do. So how do we do that? Well, I need a reference to the on-screen controls first, and I want to put this in the game controller in order for me to do that. He says you also need to clear the position values of the on-screen controls object. You'll see. Let's see if I need to or not. Okay? So how does this work? So let's get into the game controller and program that. So in my game controller, then, I want a reference to my on-screen controls. And when I start off, I want to do some platform detection and either turn them off or on. Let's see. Else screen size will make it funky. We'll see how it goes. Yeah. Okay, let's see if that's true. So I want to make a header that's going to be my on-screen controls properties, right? And I'm going to say that public game object, and we're going to say that that is going to be called on-screen controls. I want that. And on start, I don't think I need an update right now for this one. So just to hide some things that I don't need. On start, I want to use a switch case. Here's platform detection, where I want to say, hey, if my application.platform, that's the what I want to switch. There's the keyword, application platform. And I want to say case application platform Android, then do something. I also want to fall through for iOS. So I can say case runtime platform is iPhone player. And as well, I also want to case runtime platform. Actually, I'll leave that out for now. Then I'll say something like, if this is true, then I want to say that on-screen controls.setActive is equal to true. The other thing I want to do is, if my on-screen controls are on, then that's okay, right? I also want to make sure that my cursor lock is also, whenever I'm going with this thing, when I'm using my on-screen controls, I want to be able to not have my cursor locked. Okay, I don't want to do that. I want to see my cursor when the controls are there. So I want to say something like cursor lock mode, or right? That's what I want. Cursor lock mode does, I can choose locked, none, or confined, right? So I want to define a cursor mode right, for this. So I want to say cursor dot lock state is equal to cursor lock mode, and I want to say none, because I want to be able to see my cursor when my on-screen controls are on, right, in at least inside of my player, right? So I want to do. I won't be able to see this in a device anyway, but if I'm pressing the controls somehow with my emulator or my simulator, I want to see them. The other thing I'm going to do is, what about if in the case where it's something else? If it is Windows, if it's WebGL or something else, I want to use default. So I'm going to say that if it's anything else, then do a couple things. Then change these things around. So say things like my on-screen controls set active to false. And that means I'm using keyboard and mouse. So cursor lock state should be locked. Okay, let's turn that lock state on. Okay. Why not use preprocessor code for this? You could if you want to, but I find that this is a really easy way of using this. What preprocessor code would you use? How would you do it? Because it does the same thing, right? Runtime platform, whatever it is, and I can do a switch case and do that, right? You can actually copy out lines of code. You can kind of extract lines of code with your preprocessor code, but I figure that this is quite simple to do. Yep, only one time. So let's see how this is going to look and if it works at all. So now here's where the problem is. There's one thing I was missing. Let's try this out. So if I run this again, notice that my on-screen controls will do nothing because I need to get a reference to them. How about that? Haha. On-screen controls is this thing right here. Boop, there we go. And if I run it again, then if bad things will happen to good people, I didn't plan properly, and boom, my on-screen controls are gone. Why? I forgot that I have to put in my platform for for this. So for example, runtime platform, Android, iPhone, but there's also the window player, which is my editor. So I can do that too. Notice I'm using fall through, runtime platform. So runtime platform dot Windows player. So if I do Windows editor, that's the one I want. Windows editor is our simulator. Right. So again, because I'm using mobile, I want these on-screen controls to be here for the Windows editor. They disappeared because I told them to. So now I'm running, and you can see that these things are working okay. Okay, it's kind of weird because I can't control both at once, but if I had a phone to show you, I could, right? Nice. All right, cool. So let's test this with a build. Let's go File, Build Settings, and we'll do a PC, Mac, and Linux build standalone. So instead of doing WebGL, this will be a little bit faster. So what I'm going to do is I'm going to go to Player Settings, and let's change the company name to Ontario Tech U, and our product name is this. That's fine. We're using a linear color space for Windows. We'll choose the override our bundle identifier to this. I'm going to choose IL2 CPP and .NET 4X. That's what I like to do. So let's wait till that compiles. Using the old input manager. And one thing I want to change is my my screen settings. Okay, so right now I'm going to choose my resolution. Instead of full screen window, let's go with a windowed window. 1024 by 768 is the version I use for my is what I'm using for my WebGL by default. But how do I calculate what it's going to be? Well, we know that if I pull up my ratios, and if I said that the width is 3040 and divided by the height, which is 1440, then I get a ratio of 2 to 1, 2.1 something or another, which means if I want to find out if I want a width, let's say, of 1024, right? That's my width. And what would be my height? How would I figure out my height? So again, you can reverse this. So if I say my width is this, my height is smaller, so it'd be like 1440 divided by 3040 would be this ratio multiplied by 1024. and you're going to get a ratio of the height is going to be something like 485 pixels. So 1024 by 485 will give me the same ratio as my phone. So it looked like a phone when I'm running the app. Okay, that's what I want. Cool. So save, and let's do a build. So we'll say file. We'll say, first of all, let's add the open scene because we need to do that or we won't build anything. And we'll say build and run. Okay, so again, I'll choose new folder. I'll go call it builds, and we'll kind of select that folder. And let's see how it's going to work. So remember, this is a Windows build, right? And if it's going to be a Windows build, I don't want on-screen controls with the Windows build. I want to be able to control it with my mouse and my keyboard, right? So this is how we're going to do platform detection. So good. Anyone else? I'm sparking out here. Anyone else has any questions before we move on? Did you want me to show you something else? They should cover a lot of it for you. Self-destruct the object. Sure, I could. And there it is. There's my little window build. And hey, look at that, right? I can move around. I can move up and down and I don't have on-screen controls because we're pretty good to go. Just so I can inspect the entire game. Awesome. And I built it for Windows. But it looks like kind of like a little phone, right? All right, so this is something interesting. How do I exit out? Notice that I have my, I can't escape from it, right? Because I have no way of doing so, right? So I have to kind of flash out of there to do it. So that's an issue. And I could create an exit button or something like that with a panel. I was going to plan to do a panel with this as well, my canvas, but I think on-screen controls kind of hit it. So I think in the camera controller, we're asked for a panel. I'm going to say, yeah, no, I don't think I need that for now. Goodbye. This is pretty good. All right, what about in the case of a mobile build where I need something? Well, we have LD player here, right? And I want to kind of flash this to LD player. How do I do that? Let's do a mobile build really quickly. Build settings. And we'll switch this to Android. And we'll switch platforms. Now, Android needs some configuration. Okay, so we've done before. And then we're done for the day, guys. But this should give you some examples of platform detection and on-screen controls and how we take them on and off, right? For touches, what you want to do is input.touches is what you're going to get there is a collection of touches where you can do multiple touches. And the touch itself, for every touch in touches, right, I can have as many touches as I want. So I can actually have my own custom touch controls as well by using something called input.touches built in. Okay. Again, not a lot of time to do this, but let's take a look at player settings and fix this up. So week 10, we're looking at Android. This is good. I don't want to support portrait orientation at all, only landscape left and right. And my other settings here, I want to make sure that I don't care about Vulkan, so remove Vulkan. I think for most phones, most new phones will support it, but I don't trust it, so I remove it typically. So I don't have Vulkan, only OpenGLES. All right, for the mode, I recommend this. Cause you less problems. And then when I go down here, my package name, I want to put a package name in there. So COM, instead of COM, let's go to CA, Ontario Tech U, INFR, and so on. Week 10. That's good. Mono is going to go to IL2CPP or else I'll never build. And this needs to be .NET Standard 4. Those are all the same changes we made before. We want to add in an ARM64 processor support. Okay, so that's what this does. Let's wait for it to recompile. That's good. And just want to make sure that nothing else is coded incorrectly. I think we're pretty good. I don't think I missed anything for the most part. Okay. I think we're good. Okay, yep, let's save that and leave, go back to here, and we'll do a build and run. Build and run for Android. I'll make it in the build folder, single. It'll be reversed this time. Build And I'll call this week 10. That's what the APK is going to be called. Save. And it's going to build to my default device. And my default device is my Samsung emulator on my LD player. This is kind of showing you all the details, how you do all that stuff. And let's see if this actually builds. It takes a little bit of time, I find, the first time, but then the second build is a little easier, and then it's build everything correctly. Don't need this anymore. We can get rid of that. And what we want to look for is LD player playing our little game. Now, one thing to note is LD player supports both, keyboard and mouse controls as well as touch controls. And I like that because it allows you to play any game you want, even if there's complicated controls. So if the game supports both keyboard and mouse and touch, we're good to go. And in our case, our game we just made does. And again, I'll put all this up on GitHub for you guys, so you can always download my project and use that as an example. Okay, almost there. It's compiling native assemblies. And then we'll be good to go. While we're waiting, any questions at all? And again, I'm always sparking out because of the build process. It takes a lot of processing power, even for me. Okay. This is good. Okay, once we get the Gradle build, man, that's pretty good. If I get the Gradle build, I'm almost there. And awesome. There it is. And you can see that I have on-screen controls just like before. I can move left and right and do one of these, right? So I can kind of navigate through the scene, and I can move back and forward and left and right. Again, it's a little jilted, but that's okay. And it doesn't look bad on LD player, right? In terms of the way it works, okay? Obviously, what we want to try out is a real mobile device. And otherwise, these on-screen controls are very difficult to control. But guess what? I can also use my mouse and keyboard to do the same thing. Now, the mouse seems super sensitive on LD player. And this is something where you'd have to check it out. But I can also go up and down because I support both up, down, left, and right. So those controls are in play. Pretty cool. All right, so that is the demo for the week. That kind of shows you that it does both things, up and down, left and right, and all that kind of stuff. Again, any questions around this? So the on-screen controls disappear for the Windows build, but they appear for the LD player, which is a simulation of the Android machine. Okay, so that's detection. And all I did for the canvas was I literally just created an on-screen control, kind of a parent game object that I can show and hide. I'm actually literally just doing this with it in code. That's all I'm doing with it. Okay, it's nothing crazy. You can add buttons to your controls as well in the same fashion, right? Where the buttons are clickable, just like what Stephen's shown you, and you have access to whatever you want to do. You can also pull a panel into your screen. You can also add things like a mini map and those kind of stuff into your game if that's the kind of game that you want to make. All right, that's it for me. I'm going to file, save project, and let's exit Unity. And we always exit before we push it to GitHub, because I find it's the safest thing you can possibly do. View changes, and we'll say added on-screen controls, camera controls, camera fly controls. There we go. And we'll say stage all changes and push. All right, so you've got my GitHub repository if you want to reference it, but I think there should be plenty of stuff that you get now for the basics of how to make everything work. Any questions before we go for the day? All right, guys, thank you so much then. Why are we here? We're here because I was showing you this thing. I'm showing you how to do on-screen controls and how to do a mobile build with platform detection. All right, that's it, guys. Thank you so much. Take care. See you next week.